Thanks everyone for coming along. Today we're going to be about achieving idempotency in the venue so we're quite a mouthful and learn from people outside of tech. Dive into what is and
always be checking
myself introductions.
the idea, go and run the see the idea.
Digital. I've advised multiple organisations in Australia on GCP best practices and how to use it. Got 6 GCP certificates. And I've come across myself as a cloud-native solution software.
And we big software. So some of it,
what is event-driven architecture? The show of hands, anyone know about that? Yeah, what's up here? Awesome. I'm going to do the definition of here. Event-driven architecture is software design pattern with microservice reactive and state called events. Various approaches to event-driven architecture, from really complex streaming models relying on technology like Kafka to like published to
it's the plugin Firebase.
Very complexity and protocol.
Google services plugin. Yes. But what you've done is build
the benefits of event-driven architecture. So, event-driven architecture allows you to decouple services independently, scale independently, process independently without having that
what's implied
it also allows them to be fanned out without necessarily needing to is the order of things. You can kind of just put it out there and take it up and post it as they like. It assists in developing more robust and durable systems by allowing event replays and deadline queues and all that sort of kind of stuff. And ultimately instant scale. So while we are working in those hyperscale environments like GCP, having an event queue allows serverless services to react in time and spin up and allocate up the outside of the full investors that come through data to max value from these event assumptions. So it's real world examples that I've so we had a training recommendation engines that I worked with, where people use custom search and we kind of go in behind the scenes, training models that would be recommending products for that search. Photo resizing, so in that instance, we had people upload photos of products and we need to come up with a thumbnail. So you process that asynchronously to have that element to it. The other one that was really cool that I really liked working with was site-specific sentiment analysis. About 4 years ago, 5 years ago, chatted with really awesome group. Shout out to them. And basically what happened was we had a site message come in, it would trigger a function which would respond to Slack because they had a big like 2-second response time they required. But it would put the message on the queue, another cloud function would pick it up, and then set up a language API that GCP offers, come up with cross-segment analysis, follow the message, and follow that analysis that people respond back to Slack with, and where it would dedicate it's really cool, but the reason you needed to do this was that it processes a natural language API. That was quite a hefty transaction while that respond. So we did that off immediate response and with an worked really well. So what's the problem with event-driven architecture? What sort of things to consider? One of the key issues that can cause a massive issue is these hyperscalers guarantee at least once delivery. So they don't guarantee that this will be coming through exactly once, which can cause a lot of issues downstream. So you can see the diagram, maybe the subscriber gets a message 3 times, and then if you don't correctly handle that, it can cause a lot of issues to feel state of data. It also, as I've kind of done in my experiments, it's demonstrated by the technology. So when you start to complex and intensive messages, when you weren't acknowledging fast enough, it was actually quite risk to come through. And how likely are they? So in this experiment I ran, just basically firing like 5,000 messages a second to a consumer through a queue. And as you see on the x-axis, we saw the job duration as it went up. We actually saw a massive spike in the number of repeat messages that were coming through. Interesting enough, I tried it the next day, and at a 12-second job duration, I get 0. So it's very much a bit of a black box here going on, but that's definitely something you need to account for because it is a black box. It's not so what do we need? We need messages it's processing to be idempotent. What do we need to be idempotent? Idempotent basically means in this context is multiple messages coming through should not affect the end state past the first messaging process. So once that first message is processed, we want to change the data store, we want to do everything we need to do. If the next message comes through, we don't want to affect that data store. We keep those data consistent throughout it, and we want to make sure that it doesn't lead to everyone's behavior downstream. For example, say we have an order created event through our system, and that goes off in invokes dispatching or invokes inventory updates. We only want that order created event to process that first time it comes through. We don't want to see multiple updates into trees post that process. So, solution. Yeah, popped up to this one. You can turn on exactly my celebrity. So, this is too simple, and I would highly recommend it and do it. However, that is not always the case, unfortunately. It is always as simple as that. So, things to consider. Simply increases publisher to subscriber latency. So these messages getting, because they need to wait for complete consistency throughout the system, it really does slow down that time. We also don't get good ability to do push subscription anymore. It's all pull based at that point, which in the world of serverless, kind of won't be able to scale your compute all the way down to 0 with no events. This means you will actually have to have so many tolerable costs to pick up those messages, otherwise you won't get them initiating compute. Another one, perhaps might affect some people, is subscribers must be within the same region. So you can't do cross-region processing of these messages, they all need to be in the same region, which, yeah, for some larger organizations, that might actually apply. Cool. One strategy that we can use is using versioning. So, what does that mean? Basically, with every sort of entity you have in your database, so in this example, we have the cart, you store the version that it is. And when a message comes through, it'll either say, I'm affecting this version, or I'm expecting to be referencing this version of after the process. So, in this example, we say we have a part of the cart, and we merge those two. See, okay, cool, we're on version 1, so we do accept that. Now we update the cart items, one item in the cart. Next time that same message comes through, the new version associated with it, we say, no, we've actually reprocessed this one, so just disregard that message. This also works if you have, say, a message come through that says, I want to be doing this in version 3, and we're at version 1, we say, okay, obviously we've missed a message. We just reject this one for now, but better process later. It's pretty cool. The caveat of this one, it does require full end-to-end consideration. So it's not something you can just come at the start. It's all the right application to be helping this behavior. You need to make sure everything's in versions, otherwise it can fall apart, which can be quite technical overhead and quite a heavy consideration going through new services or new features added to your product. Make sure that you're accommodating this sort of initial decision. Another strategy, which I'll dive a bit more into and I'm the demo one, is the leasing strategy. So with the leasing strategy, we kind of go through probably the naive approach to the full implementation, which is those slides here. So initially, the way we kind of approach this is we have some sort of p-value store. So Firestore, for example, this for latency, it also provides asset transactions, which is super such asset client or provides transactions, which is super helpful. So what we do is when a message comes through, we grab the message ID that comes with, and we store that in our p-value store. So that way, you know, if that message comes through again with that same ID, it's like actually already processed this one, we don't need to process again. Works pretty well. We do know that when we duplicate receives, and then we'll just go count the trigger on through. Problem. In fact, resiliency. So with these, with the modern ways of working, modern architecture, resiliency is super important. Like that says from the CTO of Amazon, everything breaks all the time. Now you need to accommodate this sort of stuff, and you need to be able to not have these systems fall over at this line of network latencies, the network can happen, scale in, scale out events happen. There's so many things that go wrong with very complex systems, we need to be able to accommodate that. So I would say, in my opinion, that is not the appropriate architecture, we should accommodate that. Second thing, so if with the message, we also store an expiration time. So when we kind of see when it's message, we say, here's our message ID, here's how long we expect to be taking to process this message. That's all. So we say for this amount of time here, we shouldn't be processing this message. Should we say, no, someone else can pick up this message. Really awesome, especially if we kind of tie it down to so cloud run, set up your request timeout duration. If you tie to that, it's awesome because it's you know that coming up with the process down at the same time. The issue with this one though is if something comes through for some reason for pubs up, after that message timeout, we're actually going to have the same issue that we're facing, just on side potency again. So not quite satisfactory, unfortunately. Third step, final, make the second call to update to say it's been handled. So as these messages come through, we set up that expiration again, which is message ID, but we also include Boolean values as handled true or false. So when the person comes through, we create a release, say handled false. Once it's in process, we go back and say, okay, it's been handled through. Next person comes through, if that gets invoked, we fail while we just kind of disregard and say, yeah, cool, we've got this, we need to do this. So cool. So next we'll learn the demo, just kind of to contextualize this for you, visualize it a little bit. The demo is going to involve having it's just a cloud run job that just fires a couple of messages to pub.queue for us. Pub.queue then invokes a consumer, which is on the cloud run HTTP service. And then we have Firestore as our least storage device. Cool. Now this one is not only live in networks, probabilistic, so you can get very much all their comments. So so this is what we're looking at here. So on the left, you'll see to start and stop the producer using these messages. We have total messages in there. We can try to count how many messages actually sent to the producer. And then on the consumer side, we have the total messages received and the duplicate number of messages received. We'll wrap it those sort of patterns. You know, quickly. And I will also disclose that I have kind of maybe it's like there is a I've actually made it so it's trending for us, so you can see on there. But it's just basically going to call itself with the text chat. So you should see those different messages come through eventually. Yeah, cool. We'll see got one come through, 3. As messages, they'll just keep going up as we process more and more messages. You can't see that it's quite a problem. But we've got multiple messages coming through and getting processed multiple times. Of course, a lot of issues. Stop that there. And now for some coding. So what is like? We have this create with lease method. dive into that a little bit. So I'm not sure how familiar everyone's with Firestore, but basically allows pretty easy way to set up transactions. I can see go through here. So we go get this lease document, which is the document created by Firestore. If it doesn't exist, then we'll just create it. We'll put in a time. It's the current time plus duration. That duration of it, conveniently enough, that one actually tells you how many seconds that you time out in the environment record. So you need to set that up. Pass that allows us to get milliseconds. That's what it works in. So we get handle to be false, true. So that's if it doesn't exist. If this we need to check has it already been handled. If the event's been handled, it's false. We don't need to process it anymore. We've kind of done what we need to do. Otherwise, if it hasn't been handled, we check the lease expiration. So, hey, is this expiring after the time, after the current time? If it is, then we throw an error. We should kind of put that back in the queue and say, hey, we might need to process this again. We don't know. Right now, what we know is someone might be having this, for instance, percentage at the current time. After that, do and true. And then when we complete it, we just basically go back and say that handled. Back into us that. So I'll comment this code. So if it shouldn't process message, then if it shouldn't process the message yet, then we return. Otherwise, we form a task and we complete the lease. This while it's running, I'm kind of talk about this thing on. So building a Docker image, pushing it up to artifact registry, UTP. Going to do what's terrible and this sets up super simple architecture. I've outlined that diagram earlier. Just updating the heritage. I should see it finished. Visual. There we go. Nice. Cool. I'm just refresh that one. Sweet. Start the producer, and hopefully you don't see any messages on through. Awesome. Notice images. No.
Is your demo source available?
It will be. Yeah. I'll put up a. I'll put in a. Contact me. Thanks. Yeah. Cool. So just a quick recap of what we went across. So achieving idempotency is difficult, but crucial in the Devfest systems. We can't really achieve the data integrity levels that we want to achieve without behavior. A real problem. Message replays can have catastrophic effects in data integrity and its function. If these messages get processed twice, it can cause so many side effects that we won't be able to really handle properly. But with careful consideration, these issues can be avoided. The other thing I will say is there was a lot of code, it's a bit complicated. I've also packaged it up into an NPM package. If you want to pull that in yourself. Points they're in very early days, but eventually I'll put a readme in there, so it's 0.1. But yeah, please done with that. Just makes it hopefully super easy. I've only got 5 at the moment, but I'm definitely keen to integrate DynamoDB in the future, which I have built separately. And then yeah, maybe do something Redis. That's the piece one thing. Cool. So thank you slide. There's my QR code on LinkedIn. If you want to reach out to me on there, I'll be able to kind of put up this repo eventually and let people explore it, see what they have any feedback for it. Yeah, thanks. Do you have any questions? Yes.
So in very slide, you showed about data duplication, right? Data getting duplicated. Is it happening because you are doing a push rather than a pull? Because this PubSub supports both push and pull mechanism, but let's say if I do the same thing in Kafka, I will get duplicates only when, let's say, my consumer failed to write an acknowledgement. That will be very rare cases. So I need to understand, it is a mainly a design problem, and then we are trying to solve it in another way around that, right?
Yeah, so it definitely is there. You don't turn on that setting I showed about halfway through the enable exactly once delivery.
Yeah.
Just in the nature of it, it can actually happen. Even in a pull mechanism, it comes up.
Pull mechanism will happen maybe less than a 1%. That's my experience has been.
Yeah.
Pushes because it's keep on pushing and saying, oh, the data might have not gone, and then we have to address it by using idempotent UUID. I'm not sure you are using UUID to find the key, or how you are generating that.
So that's from the message ID that pops up attaches each message that it receives.
Okay.
So I'm using that one, so it's the built-in one GCP. I think you are correct, and even like as I was saying, like sometimes you just don't even see the message come through times. I think the problem is the effect can be super catastrophic. So it's a very low chance, but a very high impact. So you kind of need to accommodate it regardless, I think. Yeah. Thanks.
Any other questions?
I got a sort of related question. Do you have any approaches to validation of Firestore documents with these kind of updates?
Approaches to validation of the file. Could you elaborate on that? What do you mean by that?
I mean, there's the rules, right? But beyond that, where you're making all these kind of changes to Firestore documents, so wondering if it can be kind of related to the side of potency issue. Just wondering if that's an area that you've investigated yourself, if you have any approaches.
Well, I think as it's using a transaction and opening a transaction, if there's anything that comes in to change that parcel document before it's got that lease, I think it will throw it out. So we'll say, it's got two people bidding for it. So we'll allow that sort of behavior. In terms of validating it, so I use the Firestore admin API, so I don't go through the public one. The reads are all from the public, so I've got those Firestore set up so if anyone can that's for the demo purposes, but it's not great. But yeah, for the right tools through IAM. Other questions?
Yeah, sort of. I mean, this is more like if you are taking, untrusted data through that request, got to write it to any Firestore document. Are you just writing those validation rules in your functions, or?
Yeah, I think so for this one, where you would do this, I think, would be before you enter the PubSub. So we set up the IAMs can set up PubSub and Cloud Run. And that's that's validated and verified. That's fine, it's been close to the internet. So that one's set up, and I think you can validate it before you can. Just with that verification. Once the net is trusted, verified, tell me answers.
Okay.
Any other questions?
I want to ask you to play around with serverless Redis when it pops up.
I have had experience in serverless Redis in the past. It was a while ago, so I'm not sure how it works with this, but I've seen stream Redis.
And also, have you encountered something where your by the time you subscriber actually subscribes, the publisher has already published? So subscriber times out.
Yeah. I think that's where that lease duration comes to effect. So once they find out there, hopefully it can get replayed by the copy and through.
Can you say that again?
So I think with that lease setup, hopefully the subscriber, the set up CP is able to play those messages and then fine, like I said, at this point, I can actually start sending this message again. You know,
So basically you need to, I was actually talking about the Redis subscriber and publisher.
yeah,
Have had scenarios where the publisher was publishing so quickly that the subscriber did not even subscribe
right, okay,
before that, and it was missing the messages.
right, yeah. I don't have experience with that. Hang on, I've got a problem. That's all.
Okay, no worries. Thank you.
Awesome. Anything else? Right, it's all there.
Awesome. So, thank you so much, Ian.
Yeah, thank you.